Scientists and engineers have released a source of energy surpassing anything ever before known or imagined.
Hello! In my last video I built a new workbench and restored an old forged vise for my new metalworking shop in the basement. In addition, I now visited an old local machine shop that is out of business for years. After searching through some of the remains of that shop, I bought a bunch of old power tools, manual tools, as well as some useful materials. I bought all the things that you see lying on the bench right now for a total sum of 200 euros. Some of you might think that I made a bad deal here for a bunch of beat up tools and old material, but please wait until the end of this video to make your judgment about that. Indeed, all the tools on the bench need to be repaired, maintained or at least cleaned to be reused in my shop. And that's exactly what I'm going to do in this video. I will start with those pieces that are in the worst condition and then proceed with those that are easier to fix. The one that is worst off is this heavy power drill. It really is very dirty and especially the power cord looks putrid. So why did I even buy this machine? Well, as you can see on the nameplate, it was made by Fein in Germany, which is a company which is widely unknown on the consumer market because it exclusively aims at the professional user in the metalworking business. The machine has a very low frequency of revolution, which should give it a lot of torque and make this drill interesting for some jobs normal power drills are not suited for. If you check the name of this tool online, you will find out that Fein still produces an updated version under the same name. What's the price? Well, see for yourself. The old power cord will have to be replaced. The drill chuck works, but it has some rust on it, which I will have to remove. The handle also has a crack on one side, which will have to be glued together again. The machine is also not working at all at this moment, so I will also have to get the motor running, check the switch and so forth. So let's open the enclosure and see what we can do about that. And what do we have here? Well, it's a pair of replacement carbon brushes. What a nice surprise. I will install them later in this video. Upon further inspection, we also find a couple of brass inserts to hold the screws of the enclosure in place. You don't see that too often anymore. The first thing that I do now is remove the old power cord. I will throw it right on my copper scrap pile though. This filter capacitor component is obviously damaged. It has ruptured when I turned on the drill for the first time while I was still in the old machine shop. After I heard the capacitor literally explode, I knew what had happened. This is also most probably the reason why the drill doesn't work anymore. And it is a fault that I have come across many times before, as you know when you have watched some of my earlier repair videos. It will later be replaced. But before I even start to repair anything, I want to know if the motor and the gears are still operational. For that, I now connect the motor directly to my isolation transformer. I will step up the voltage to roughly 1/2 of the rated supply voltage and see how the motor will behave. The motor is running at a constant speed. No strange noises can be heard, nor is a burnt smell in the air. These are good signs, but before I subject it to the full 230 volts, I want to take a look at the gears and brushes. The cogwheels and bearings themselves seem to be okay, but there are a couple of metal shards inside the loop. They obviously come from this thread here. It is intended for holding the side handle of the drill. I guess that someone has dropped this drill at one time, so that the bottom part of the thread broke off, with its parts falling into the gearbox. It's actually a lucky coincidence that the shards obviously didn't damage the gear, so after sorting through the loop, I have removed all metal parts. The thread is still big enough to hold a side handle though, but I guess it would be better to use a handle like the one on this picture in the future, and maybe I should also close the hole so that nothing can fall into the gear again. If I had some lubricant right here at this time, I would also replace the old one, but this will have to do for now. In the meantime, I clean the front parts of the drill before attaching it to the plastic enclosure again. Before putting the gear back on, I also install the replacement brushes. While some smaller parts are being immersed in soapy water, I go down into the basement to remove the rust from the old drill clutch. With all that done, I'm getting curious how the drill will perform with the new brushes and the shards removed from the gearbox, while applying the full line voltage. And everything runs just fine. Now I prepare an MKP Class X capacitor with some lids and connect it to the power switch as a simple replacement for the old damaged filter component. The old filter actually consisted of two series capacitors with a center tap, but this is not a key component and the drill would be fine without one as well. This capacitor does not filter the line voltage for the drill, it protects the grid from the noise generated by the commutator of the universal motor that drives the drill. Next, a new power cord is connected. The last thing to take care of is the crack in the enclosure. I do my best to clean and roughen the surfaces around the crack with some sandpaper. I first apply cyanoacrylate and add some pressure by clamping the drill into my vise. The glue will hopefully hold, but if it doesn't, that's not a big problem as well, since I'm planning to use the drill for a small drill press, in which the back handle will not be used anyway. But for now, this power drill is actually running just fine, as I will now demonstrate. Our next patient is this heavy angle grinder. It as well was made in Germany, manufactured by the Bosch Corporation. I already owned a very similar angle grinder, and my guess would be that both of them are at least 20 years old. A modern Bosch angle grinder of comparable size costs 225 euros. Many of Bosch's current tools are not even made in Germany anymore though. They are proudly made in the PRC instead. And say, is it just me or do these modern day Bosch tools look ridiculous? More like cheap toys than professional power tools if you ask me. The one I owned before came into my possession about 4 years ago, when I picked it up from the streets where someone had thrown it on a pile of trash. Since I was always amazed by its ruggedness, I didn't hesitate to buy the second unit, even though it does not work. When you plug it in and turn the switch, nothing happens. It is also very dirty, maybe even more so than the fine power drill. So let's open this thing. The black ring, by the way, seemingly holds what is described as a 16 amperes input current limiting circuit. For you Americans out there, in 230 volt grids, 16 amps is the typical size of a household circuit breaker. That's why they chose that value. Upon pulling out the switch, you can see that someone else has bypassed it. Most probably in the failed attempt to make this grinder run again. We will later have to figure out the pin out of the switch and how this inrush current limiting circuit works. With those parts removed, I again connect the device directly to the isolation transformer and step the voltage up to 1/2 of the rated voltage. But other than a short burst, we get nothing out of it. Hence, it's time to take a look at the brushes. With these old Bosch grinders, the motor brushes can be accessed through 2 plastic doors in the walls of the enclosure. After taking the parts out that hold the brushes, it becomes clear what the issue is here. These metal sheets have corroded, holding the carbon pieces so tightly in place that they can no longer slide down as their length gets reduced by the friction of the commutator. This machine would have been running until it literally cut itself off from the grid. No wonder bridging the switch didn't help anything. I now tried to get the brushes out of their sockets without breaking them, but it's hopeless. They don't move at all. I will have to beat them out by force, remove the rust, and order new replacement brushes online. And ordering some is what I did immediately. In the meantime, I proceeded with my plan. After removing the old brushes, I file out the rust that is prohibiting the carbon brushes from sliding down. After just 1 day, the replacement parts have arrived. They have the right dimensions and they cost me only 7 euros. What more do you want? With the new brushes installed, let's connect it to the isolation transformer again and go up to roughly 110 volts. Okay, so the motor is still alive. But what about the gears? To open the gearbox, only 4 screws have to be unscrewed. What I find inside still looks good to me though. I cannot see any damage or metal shards in here. After taking the gearbox together again, a lengthy cleaning process followed. This might not be particularly interesting for you, but I simply can't enjoy repairing a device if it isn't also cleaned up properly. More importantly though, the switch must be rewired and the current limiting must be figured out. Otherwise, the circuit breakers would blow each time you turn this grinder on. But as it turns out, it is actually a very primitive circuit. It is a 2-stage switch combined with a simple power resistor. When you turn the main switch to roughly 50%, switch 1 is closed and the motor is connected via the power resistor to the grid. If you now push the main switch all the way to the end stop, the second switch is activated and the resistor is shorted out. In this way, the initial current rush is prevented and the circuit breaker does not blow. But you have to take care not to leave the switch in the mid position too long, or the resistor might overheat. With the switch rewired and the unit taken back together again, it is now time for a real-life test. So now that the angle grinder is in working condition again, it is time for the next repair. This device might look like an ordinary power drill with a weird old-fashioned clutch, but it's not. It's a fine brand tapper drill, especially designed to cut threads into metal. The model number is ASGE 636, and if you look it up online you can find out that this model is also still made by Fine under the same name. But of course some upgrades would have been made in the meantime, as can be seen by comparing this picture to my machine. As for the price, you better don't ask. Judging from the outside alone, A damaged power cord, a few scratches and a little bit of dirt seems to be all that is wrong with this drill. So let's open the enclosure and check the insides as well. It might not come across as that because of the dust and dirt, but the plastic parts inside are of very high quality. There are also two small toroidal chokes as part of a filter circuit in here. Haven't seen that in this form in a power drill before. The black plastic box doesn't hold a simple switch, but a phase-fired controller, which would have been cutting-edge technology at the time this thing was manufactured. Under this black cap right here we find one of the brushes, which seemingly lead to the commutator from behind. Not exactly the usual way to do it. And again we find brass inserts for all screws. Since this all looks just fine, I simply install a new power cord and put the enclosure together again. The variable speed control works just fine. If there is no pressure applied to the clutch, the machine turns counterclockwise, but as soon as you push it to a surface, the rotary motion reverses its direction. If you then resist that motion, you can feel impacts, like with an impact tool. After separating the gearbox from the plastic part of the enclosure, I can take a closer look at the gears as well, and they seem to be just fine. With the device reassembled, the mandatory cleaning of the enclosure follows. From all this I would say that this tapper drill is working fine. But if this is as tricky as hand tapping, I will need some practice before I can deliver you a demonstration. And our next patient is another Bosch brand power tool. It as well was used for tapping, as can be recognized by the peculiar looking clutch. But other than the rest of the tools, this device was not made in Germany, but in Switzerland by the Scintilla Corporation, which is a subsidiary of the Bosch Group. From the overall design, I would say that this is the oldest tool we have seen so far. It as well has a damaged power cord and it is very dirty. After opening the enclosure, I remove the old power cord. We also get a glance at another old filter component. Interestingly, this old timer seems to be in good shape though. I wonder what makes some of the old capacitors prone to fail, while others endure for decades. I attach a new power cord and put the old handle into some soapy water. In the meanwhile, I take a look at the clutch, which was obviously fixed in the past. Someone inserted a brass screw in here. Doesn't look too professional, but it holds. I have no idea what a machine like this would have cost back in the day. But I found out that these clutches can still be bought online, and they are not exactly cheap as it seems. Upon taking off the front part of the drill, we can also find a date code from the year 1970. The gears again do not show any unusual damage or wear. The design of the motor's stator looks very old-fashioned. You don't see that too often in modern universal motors. Other than with the rest of the tools we have seen today, the rotor can easily be accessed. This has the advantage that I can clean the contacts of the commutator without any trouble. And again, cleaning the tool all over is part of the deal. After taking the parts back together again, it's time for the moment of truth. So, okay, now that my new power tools are all in working condition again, we can still take a look at some of the manual tools which I also bought in the machine shop, do some maintenance work and so on. A square like this, in this case made by MBR, should be present in any workshop. A new one costs around 20 euros. This one has some superficial rust, which I now remove. For this kind of job, I recommend these sanding blocks, which you might have seen me use before in some of my videos. After removing the rust and cleaning the surface with a rag, I apply a thin film of ballistol to its surface. Ballistol, by the way, was used by the German army from 1905 to 1945 as an all-around oil, mainly for firearms maintenance. Today it is more often used for more peaceful purposes though, and is a typical German export product. This magnetic angle basically receives the same treatment. These Knipex brand pliers are used to open retaining rings. Even though this one is maybe 30 years old, it looks just like some other Knipex pliers I bought just about 3 years ago. And yes, it's called Knipex with a K, but I guess it's okay to say Knipex. It just sounds better. Had this company known before that they would have to compete in a global economy, I'm sure they would have chosen another name. The wrenches I scored are also an interesting find. These are all name brand items and they are typically around 10 to 15 euros each when you buy them as new parts. Dovidat is basically the same as Gedore. The brands Rasol and Harzet are also traditional German tool manufacturers. And since I feel like it, let me tell you some tool making lore about these brands, where they come from and what their names actually mean. If you have a wrench saying what you would read maybe as Gedor or Gedor is actually pronounced Gedore, and it stands for Gebrüder Dovidat, City of Remscheid. Gebrüder means brothers, as in Brothers Grimm. Dovidat is the name of the founders and Remscheid is the city where these tools were made. Remscheid, by the way, is a traditional industrial city in the Ruhr region of Germany. The name Rasol stands for Richard Abraham Herder, City of Solingen, which is often called Messerstadt, which means as much as Knife City, because a lot of knife manufacturers are situated there. In fact, the place is famous for its bladesmiths ever since the Middle Ages. Harzet stands for the German pronunciation of the letters H and Z, which is H and Z, which again stands for Hans Zerver, also situated in Remscheid. This company is a traditional competitor of Gedore, no wonder since they sell similar products and come from the same place. Another famous German toolmaker is Stahlwille. The name derives from Stahl, which means steel, and Eduard Wille, being the name of the founder. I don't have any Stahlwille tools though, since they are out of my price range. Stahlwille exports roughly 80% of its products to foreign countries. I'm not sure about it, but I guess it's similar with the rest of the manufacturers here as well. Okay, so much about that. Some of the wrenches show some wear and their surfaces are damaged or corroded. I remove superficial rust and again apply a thin oil film to the surfaces. They are not new, but I guess they can still do the job. In the end, I feel satisfied that all the tools are working again. And even if this wasn't the best deal in the world, since I had to put so much work into it, it was still a lot of fun. This Kaiser brand compressor is in working condition. It has some minor issues though that still should be fixed, but the amount of work that went into this video was already too much and I simply don't know at this moment if I will make another video about this compressor. But be that as it may, I hope that the repair fever is contagious and that I could motivate you to try repairing some old tools yourself again, and that I see you next time as well.